Hello everyone, welcome back. Today we are going to conduct a mini quiz review to get us ready for the quiz on Friday, which is tomorrow for you guys. So I'm going to cover a couple more problems. Now, this quiz review is not going to be comprehensive of everything on the quiz, so just remember that. You might need to go back through some of the previous lessons to make sure that you see some of the other similar problems that might be on the quiz at the end of this week. And I'm going to talk about some problems here today that I think you should probably review, make sure you know really well, so that you do well on the quiz. All right, so that's our goal for today. Just get ready for the quiz. So we're going to take a look at our first problem here. We are given a function. So f of x equals x squared minus x minus 12. And the first thing that they want to know is what is f of negative 4, right? So remember this is read f of negative 4, which means they are taking negative 4 and inputting it into the function. So this is an input, and we want to know what the output is, right? So to do that, we need to take this negative 4 as an input, and we need to put it in for every instance of x in the function, right? So we have two different places where x exists in this function. So when I rewrite this thing, I'm going to say f of negative 4 equals, and so this first x is going to get replaced with the negative 4, so I'm going to have negative 4 squared, right? So instead of x squared, I have negative 4 squared. And then minus, now there's an x there, so then in parentheses I'll have another negative 4, right? So minus x, and x was negative 4, so that's why we have two minuses there. All right, so a lot of students will make a mistake at that point and forget one of the minus signs or one of the negatives there. Don't do that, right? There's a negative on the input and there's a negative in the function, so you should have two there. And then we have a minus 12, that's on the end. Okay, and now we just got to be careful. We're going to evaluate piece by piece here using our order of operations, and we're going to make sure that we take into account all of those negatives that we see. All right, so I'm going to start here with the exponents. We have negative 4 squared. And remember, whenever you square a negative, you're going to end up with a positive, right? Because a negative times a negative is a positive. So negative 4 times negative 4 is a positive 16. Right? That's a very common mistake that students will make right there in that problem. They'll put a negative 16 here and forget that, when you square that negative, you get a positive. Now we have minus negative 4 minus 12. And you'll notice I dropped the parentheses. And the reason that I dropped the parentheses there is because there's really no point in the parentheses. I don't have an exponent. I don't have anything really being multiplied into that parentheses, so it's not necessary. All right, so I'm going to go down to my next step, and I'm going to add and subtract from left to right. So I'm going to start with this. This is minus a negative. When you subtract a negative, it's the same thing as adding. So really, this is 16 plus 4. Okay, so 16 plus 4 is 20. And then I still have my minus 12. And then I'll just take care of that last subtraction. 20 minus 12 is 8. So I put a negative 4 in. I get an 8 out. So we can say f of negative 4 equals 8. All right, and that completes that problem. Now we take a look here at part B. We're still working with the same function, but they want us to find x if the output is 0, right? So here the number they give us is not inside the parentheses. Instead, it's this part. They're giving us the output, right, instead of the input. So this is an output. And our job is to find the input. And to do that, we need to take the function, so x squared minus x minus 12, and we have to set it equal to the output, which is 0. Okay, and hopefully you recognize the situation. We've solved many of these types of equations before, and you have two options here. You can either attempt to factor or you can use the quadratic formula. Either one will work here to solve this equation because this is a quadratic set equal to 0. The quadratic formula will work, and my disclaimer for the quadratic formula is that it is longer and it can be a little bit more tedious than factoring, right? If you're good at factoring, factoring is much quicker and less prone to mistakes. Okay, so I'm going to show you factoring because I think you're going to want to use that instead of quadratic formula. All right, so here we go. So I'm going to set up my box in Diamond. All right, so there's my box. There's my diamond. Okay, so to factor, we're going to take the x squared term, it goes in the upper left-hand box. The constant term on the end, that negative 12, is going to go in the bottom right. The middle term, that negative x, is going to go in the bottom of my diamond. That's what I want my two boxes to add to. And then what I want my two boxes to multiply to is the same thing as what this first diagonal multiplies to. All right, so when I multiply this first diagonal, I get negative 12x squared. And I always like to put a 1 right here in front of the x when I'm doing the diamond. So I'm looking for two numbers that multiply to negative 12 but add to give me a negative 1. And like I said, this part requires a little bit of trial and error if you're not really good with your multiplication tables. All right. So the correct pair of numbers, and hopefully you thought about it for a little bit, is negative 4 and 3. Okay, so think about it. Negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. So this is the combo we're looking for. There we go. So now I'm going to fill in my outside numbers, right? So we've got x and x, right? Because x times x is x squared. X times 3, right? So I'm looking at x times 3 gives me 3x, and x times negative 4 will give me the negative 4x. And then I write my factors, right? So now, instead of this equation, I can write this one. I can say x minus 4 times x plus 3 equals 0. And then using the 0 product property, I can solve these by setting them both equal to 0. So I can say x minus 4 equals 0, and x plus 3 equals 0. And if I solve each of those, I'll get x equals 4 and x equals negative 3. And there's my two solutions. So we actually get two different inputs. There are two numbers that I can put in for x that will both get me a 0 on the output. All right, let's move on. All right, so this next one, we have a function again, and this time, make sure you pay attention to the instructions here. It says complete the square. Okay, so they're telling you exactly what to do. They want you to complete the square and find the graphing form of the parabola. So remember, the graphing form looks like this, right? A parentheses x minus h squared plus k. So they're telling you what your equation is going to look like when you're done, and they're telling you how to get there. All right, so I'm going to take this function, I'm going to complete the square. So we need a box. Okay, and since we're completing the square, we don't need a diamond over here. All right, so completing the square, slightly different. I'm going to take the x squared term, it goes in the upper left-hand box, and then I take this middle term and I divide it by 2, or chop it in half, right? So if I take negative 6 and I chop it in half, I get negative 3x and negative 3x. Okay, and I put that into that second diagonal, split evenly. And we're going to leave this box alone for right now, and I'm going to go right ahead and start on these outside dimensions, right? So just like when we factored, we're going to need an x and an x, because x times x is x squared. Now over here, we have x times negative 3 to get a negative 3x, and same thing down here, we'll have a negative 3. And this is why they call it completing the squares, because instead of a rectangle now we have a square because both sides are equal. Okay, so this is a square. Now if I do negative 3 times negative 3, I get a positive 9, right? And that completes the square. And then I'm going to start writing my equation, right? It's going to kind of look like this. We have y equals, and in parentheses I'm going to put in x minus 3 squared. And the reason I can say x minus 3 squared is because it's x minus 3 times x minus 3. So it's x minus 3 times itself, which is the definition of squaring. All right, so that's how we get to an equation that looks like that graphing form, or that x minus h squared is right here. Okay, now we got to take care of the plus k part, and to do that we have to compare this number, the 9, to this number on the end of our original equation. We got a 9, but we needed a 4. So we have to go from 9 down to 4, and to do that I'm going to have to subtract 5 off the end. So now it looks a lot like this thing here, right? And we can see all of the graphing information that we've been studying for the last 2 weeks. We can see our horizontal translation, we can see our vertical translation, and that means I can tell you exactly where the vertex is. So this is the x-coordinate of my vertex, It's going to be at positive 3. Remember, it's the opposite of what we see in the parentheses. And this minus 5 tells me it's located at negative 5 on the y-scale. So my vertex is at 3, negative 5. And you can see where we get those numbers from our graphing form. All right. Now, the other thing that you're going to want to make sure that you study for this quiz is this table. You've seen it on every set of notes that we've done this week, and we've talked about all of these different types of functions. We've seen examples with all of these different types of functions, but you really need to make sure that you look over this table and make sure that you are familiar with these graphing forms, the shapes of the graph, right? You want to make sure, like, hey, if I see a v, I know that's an absolute value function. Okay, if I see this weird thing right here, well, that's going to be a cubic function, right? So you really need to know these shapes, because I'm going to give you a graph and expect you to write the equation of that graph, and you need to at least know where to start, right? You need to know which blueprint to use. All right, so let me give you an example. All right, so here we have a graph. It says write the equation, and I instantly recognize this V shape. That's one of the graphs that we talked about, right? So if I go up here, here's the V shape, and that's an absolute value function. So this is my blueprint for writing that equation. All right, so I'm going to go down here, and I'm just going to start with my blueprint. Y equals A, absolute value bar, x minus h plus k. Okay, so this is what my equation is going to look like. I need to find these three things, A, H, and K. All right, so let's start that, right? So remember, it says you can assume the stretch factor is 1 or negative 1. So I look at my graph to determine if it's been reflected. Okay, it's opening downwards, and if it were not reflected, it would be opening upwards, just like a parabola. So I know I'm going to be putting a negative 1 out front here. So A is going to be negative 1. All right, and then I'm going to work inside of my absolute value bars here. So I'm looking at my locator point, right? We talked about that locator point being the vertex, just like with the parabola, that vertex of the V, that's my locator point. And also recall that if we were working with just the parent function, right, before it's been moved left or right or up or down, that locator point would be located at 0, 0. Okay, so what I like to do is I like to put a point at 0, 0, and then a point at where the locator point is now, and I say it has moved, it has shifted. And I take care of the horizontal first, right? So I say, okay, well, if we started here at 0, 0, we must have traveled to the left 3 to get to this point. So to travel left 3, I need an x plus 3. And then I also notice that it has gone up 1. Right, so I went left 3 and up 1 to get to my new location, and to go up 1, I need a plus 1 where the k is. And now I have my A, my H, and my K, so my equation is complete. This is what I'm looking for. All right, one more here. Now this one is different. It's an equation from a description, so I'm giving you a bunch of clues here, and I want you to write the equation. So you got to read through these clues. I'd read them all first, and then start with your blueprint, right? So one of the clues here is that it's a square root function. All right, so if I were using that table up above, I'd say, well, my equation is going to look like this. A square root, x minus h in the square root, and then a plus k outside of the square root. So this is what my equation is going to look like. I still need to find the same three things, A, H, and K. All right. So here we go. Let's see if I want to find this. I'm looking for a stretch or a compression factor, and I look through my clues, and it says it has been compressed by any factor. They didn't exactly tell me which factor it's been compressed by, and that's okay. They say any factor, it's been compressed. So I can pick any number that's going to compress this thing. And I remember from the lessons that to compress something, we need a factor that is in between 0 and 1. Okay, so you can pick any number you want between 0 and 1. So I'm going to pick 0.2. That number will compress it. You could have 0.3, you could have 1 over 2, you could have 3/4, any number you want that's in between 0 and 1 here, all right, because it says by any factor. All right, now the next thing I'm going to look for, here is the locator point. All right, so the locator point tells me the H and the K values. Okay, so the H representing our horizontal translation or transformation. is -3, right? So it tells me that the parabola has been moved to the left 3 units, and to move left I need an x plus 3. And this -2 tells me that the square root has been moved down 2 units, and to move down 2 units I would go -2. And that completes my equation. Now you probably notice there's an extra clue here. Number 3 says it's been shifted down by 9 units. Well, that was a mistake. I shouldn't have included it. I forgot to delete it, so just ignore that one, and hopefully that didn't confuse you too much. I forgot to get rid of that. The horizontal and the vertical translation are taken care of here by the locator point, so that third clue was not necessary. So this is the equation that I'm looking for. Alright guys, that's it for review for today. Good luck on your quiz tomorrow. Make sure you try the daily practice problems, and make sure you're ready for that quiz. Good luck, guys.